In the next three videos, we will take a look at how a function's inputs and outputs can be related to each other. And this brings us to injection, surjection, and bijection. Now, a function is said to be injective or one-to-one if each distinct elements of its codomain can be mapped to by at most one element of the domain. So this is the formal definition. Let's take a look at some examples to try to understand how we can identify injective functions. So let's consider the function f, whose domain is defined to be R and codomain is defined to be R as well, and the function f is given by f of x is equals to x. So we can see that for each distinct outputs that the function attains, which is x here, it comes from a distinct input from its domain, which is x as well. So this is a simple function and this is an injective function. Now let's consider the exponential function here, which is defined as a function g here with the domain R and the codomain R, and the function is g of x is equals to e to the power x. So here we are defining the codomain to be the real coordinate system, but the function actually attains only positive numbers because it's the exponential function. So the image is the open interval 0 to infinity. So this function is also an injective function because all of the values that the function attains can be mapped to at most one distinct element in the domain. So let's take a look at two figures to further understand this. So here in the figure on the left, we can think of this as a representation of the function f and this as a representation of the function g that we just described. So here we can see in the domain each element a, b, c, d can be mapped to one element in the codomain. And so this is a simple case which satisfies the definition, and so we can say that this is an injective function. But what about this case? So we can see that in the codomain we have 4 elements, but in the domain we have 2 elements, and the function attains only 2 of the values from its codomain, and it cannot attain these 2 values. But however, the values that the function attains, which is w and z here, can be mapped to one element in the domain, and it's mapped to at most one element. It's not like that this w is mapped to 5 and 3 as well. It's only mapped to one element in the domain. So according to this definition, some elements of the codomain are mapped by one distinct element of the domain, but no elements of the domain remain unmapped. So this is when we can say that this function is injective function. So simply put, not all elements of the codomain need to be mapped to an element of the domain. However, if any element of the codomain can be mapped to, then it will be mapped to at most one element of the domain. So given this definition, if we consider the function f and the elements a and b, where a and b belongs to the set x, where x is the domain of the function, then if we say that the function f is injective, then that also implies that if f of a is equals to f of b, then that implies a must also be equals to b, because the outputs can only be mapped to one distinct unique element in the domain if it can be mapped. And hence, if two outputs are the same, so then they must also come from the same inputs, and hence a has to be equals to b in that case. So this is a quick overview of injective functions. If you like my videos and find them helpful, then please support my work by subscribing to the channel.